Alrighty, welcome back. So here's another video related to the debate between Will Duffy from The Final Experiment going up against Sean Griffin from Kingdom in Context. And this video is really just to show how pathetically weak the arguments were in his introduction. To be fair, the majority of his introduction was trying to use the Bible to justify flat Earth, and I probably dozed off during that part. And woke up when he started talking about empirical evidence. And the biblical stuff was obviously because the debate happened on the Standing for Truth channel, which is a young Earth creationist channel. Link to the debate is in the description. So this video is just going to be like rapid fire clips followed by rapid fire explanations. And the first clip is Sean using high altitude balloon footage to show a flat horizon left to right, rather than a curved horizon.
Here's another quick example of a high-altitude balloon. As we see the sun moving away, fulfilling Psalm 19:6. Also, conveniently, there's no left and right curvature anywhere in this video at a high altitude.
All right, now I scrolled through the first dozen pages or so of YouTube balloon videos looking for this particular one, but I couldn't find it. So I'd appreciate if Sean could provide the source. In any case, he must have been living under a rock for the last decade or so, because surely he would know that the vast majority of these high altitude balloon launches use a wide angle lens like a GoPro. And as Globers have been telling Flurfs, and Flurfs have been telling Globers, wide angle lenses distort straight lines. A horizontal line below the center of frame will be bent upwards like a smile, and a horizontal line above the center of frame will be bent downwards like a frown. So here is an example where the horizon is well above the center of the frame, and you can see that the curvature is quite exaggerated. But here's a frame from the same video, just 2 seconds later, where the horizon is below center frame. Where the lens should be curving a straight line into a smile, but we still see a curved horizon. I think it says a lot about your efforts to engage with those that hold differing opinions that you even brought up balloon footage. Now, to get around the problem of GoPros and other wide-angle lenses, Mr. Sensible sent up a weather balloon a few years back with a camera that has a rectilinear lens and that has negligible distortion. The really cool thing that Mr. Sensible did was stretch some strings very tight across the outside of the lens, such that even if there was distortion introduced by the lens, we would be able to see it if the strings were distorted in the footage. And as you can see here, that blue string at the bottom is very slightly curved upwards, which means that the horizon is even more curved than it is in the footage. But my favorite high altitude balloon footage is from a flat earther named Dwayne Kellum, who sent up quite a few balloons, but this one in particular had a Sony A7 camera on board. And as you can see, the horizon is curved. All right, on to clip number 2, where Sean seems to think that the new moon is a problem for the heliocentric model.
And it goes dark for almost 2 full days and nobody can see it. This is something I asked Will Duffy on my channel last year, and he didn't even know that the moon cannot be seen for almost 2 full days in the sky. Not even anyone that believes in the heliocentric model, no one's ever taken a picture of the moon while it goes dark.
Right. I'm not sure how long you've been a flat earther for, but surely someone has explained a new moon to you. All right, so I'm going to show you 2 photos. I took them with my P900. This first one is of the moon about an hour before sunset and a little over 2 days from the new moon. So there's only a tiny sliver of the moon phase visible from Earth. And here's the second photo taken about half an hour after sunset. And I increased the exposure of this shot just so I could expose the unlit portion of the moon. And that's why the lit portion looks a little bit blown out. So Flurfs, yes, the moon is still there even when it's a new moon. You just can't see it. Because the new moon is necessarily close to the sun in the sky, which means if the new moon is in the sky, then it's also daytime. And if it's daytime, then the blue sky stops you from seeing the unlit portion of the moon. And this is one of those fluff arguments where you've just got to ask yourself, did you, Sean, discover a flaw in the heliocentric model that literally millions of smart people have missed? Or maybe you might be misunderstanding something. Like, which one is more likely? All right, number 3.
The inverse square law of light. Light gets less in luminosity as it gets further away by orders of magnitude. So there's actual equations for this. It gets less in luminosity the further it gets from its source. There's entire science behind this. It's called the inverse square law of light. So the moonlight that we see, the illumination of the surface of the moon should be 16,332 lux.
Rightio. So clearly Sean failed high school physics because otherwise he would know that the inverse square law states that for a point source, the intensity decreases with the square of the distance from the source. So from Earth, the moon is about half a degree in angular size. So you can probably treat that as a point source and apply the inverse square law from that distance. But as you keep halving the distance, the angular size of the moon keeps getting bigger, and you can no longer treat it as a point source. And the inverse square law simply does not apply. Now, there are different estimates for how close you need to be for the inverse square law to start breaking down. One of the most common estimates I've seen is when your distance is about 10 times the diameter of the light source. So for the moon's diameter of about 3,500 kilometers, as soon as you're closer than about 35,000 kilometers from the surface, the inverse square law just no longer applies. You can't just keep halving the distance and quadrupling the intensity. And I'm guessing Sean failed high school maths as well, because that limitation should be fairly obvious from the formula itself. A good way to illustrate the problem is making an analogy with one of Zeno's paradoxes. So in this paradox, the runner always covers half the distance to the finish line. So, after some number of steps, the finish line might be 1 meter away, and then half a meter away, and then a quarter of a meter away. And each time he covers half the distance, he quadruples the intensity of light. And since you can theoretically halve the distance infinitely many times, you should be able to see why the intensity would actually approach infinity according to this formula. Don't apply the inverse square law of light when it's not applicable. All right, on to number 4.
So this is Joseph Hanvey shown in a firmament enclosed model of Earth with a light circling on the top.
Wow. I don't have a whole lot to say about Joe Hanvey's quote-unquote model. Suffice to say that the sun in Antarctica didn't do this. All right, Mumbo number 5, Venus.
It's pretty interesting. This is what you've been shown by NASA that Venus looks like, yet in 2021, someone recorded Venus actually looking like this. Look at that. Is that a ball in space?
Dude, I think I know who took that footage. But just for shits and giggles, I got up pretty early this morning to get some actual footage of Venus. That's it on the left there. And you can also see Saturn and Mercury on the right there. And it's a little bit overexposed. But yeah, I'm going to say it does look like a ball in space. There you go. Anyway, that's enough of that. Let's do one more and then call it a day.
So we see something like the Aquarius constellation, which is an equatorial constellation. And we see that this particular constellation, and these are all the stars that make up that constellation, we see that this one is seen every year of the month. Every year of the month.
Every year of the month, people. Every year of the month. I kind of want to give him the benefit of the doubt there that was a joke. Anyway, now, first of all, did you notice that his quote-unquote evidence consisted of asking Google AI, can Aquarius be seen during February? And Will Duffy said during the debate that his phone's blowing up with people saying that this is wrong and not to trust AI. And I agree. AI is rubbish. I can easily get AI to give a contradictory answer, and this is the correct answer. The sun is in Aquarius in late February to early March. So here's Stellarium, and first thing you'll notice is that Aquarius is upside down for me in Sydney. I wonder why that is. And I've set the date to be the 22nd of February, so the sun is right on his dick. So no, you're not going to see Aquarius on this date. The best case is that after sunset, you might see one or two of the stars, like in his feet or the water. You're not going to see it high in the sky like you would in September or October. But the main point, Sean, is that you didn't bring any evidence. And if you do end up getting some photos of Aquarius when you think it shouldn't be seen, just double check Stellarium and make sure it's not a you problem. In fact, if you find anything that contradicts Stellarium, let me know. So yeah, that'll do for now. Obviously the debate offer still stands, but I really hope you develop some better arguments. Bye.